Dear friends, welcome to Infos. Welcome to another video from Oil and Gas Training Series. We are continuing our effort on completing gas processing system. So, welcome to 39th video, gas processing part 6. In this video, we are discussing about P&ID and control system. Have a look at this is the symbol DCS printout, the DCS image on gas absorber, absorber system, and this is the typical piping and instrumentation diagram for absorber. So this is the absorber. This one is the absorber. I will just to make a little bit zooming. See the absorber. In this absorber, it is actually two part. The bottom part where the gas line sour gas is entering is a inlet no-go drum. See, inlet no-go drum is there. Inlet no-go drum is a vessel where any liquid and other contaminants we can collect into the inlet no-go drum, and there is a inlet device is there. Inlet device we have discussed in various locations in like separator. It will change the velocity and direction, and a sudden decrease in the velocity, heavy liquid particles settle down in the system. And here also one internal part is there, and then rest here it is only one here demister pad is there. So all internals are supporting to remove maximum liquid particle from the sour gas. That will increase the efficiency of absorber. So this is absorber. There is a chimney is there, so it will enter here, and it is moving up, and this is showing a packed column. So from the other side, this is the liquid amine is entering here. So this is the absorber, and here also demister pad is there. So this is the absorber is there, and sour gas is entering from here. See, look at this one. Sour gas is entering here. This type of item there, the shutdown valves and the limit switch and all other things we have discussed in our basic instrumentation and control system section 1 maybe 1 to 7 or something. Just to have a look at that one. All instrumentation symbols, typical symbols, and all other details. What are the using all symbols and other things we have discussed in earlier. So I am not taking my time to explain it again and again here also. So the discharge gas is leaving from here and cooling to the heat exchanger where amine is entering from the shell and side, and gas is releasing to the tube side, and it is going to the outlet no-go drum. That is the outlet no-go drum. It is another separate vessel which is also collecting here, and the inlet device is there and collecting the liquid, including liquid amine as well here, because any amine is carry overing with natural gas that is collecting here, and the demister pad is there, and it is releasing now H2S and clean sweet gas. Sweet gas is releasing to other process. So sweet gas is readily available here. And here see H2S analyzer is also there. How much H2S is there? That is the AIT, that is the analyzer is there. That also is there. So this is the typical P&ID of absorber. So let us discuss about various process parameter depending on the performance of gas sweetening process, mainly in absorber. Just to keep this one in post mode and review it each and everything, and any doubt is there, just to make it to your comment box, then I can do it in comment in detail later. So absorber process control system. The principal absorption, we have discussed that one. Absorption is that the 25% lean DEA solution readily absorbs H2S when when at high pressure and low temperature in absorber. That is what we see here, this one, absorber. Sour gas, after having any liquids removed in the sour gas knockout drum, that is here, sour gas knockout drum, that is here in this area, knockout drum, enter the lower section of the absorber tower at a relatively high pressure. Lean DEA containing little H2S or no H2S, we can say, coming from the regenerator, which has been cooled around 120 degrees C, 49 degrees C by the solution exchanger, and the solution from fan cooler enters upper section of the absorber. That is this one here, this area. So this is the process partially showing that inlet separator. This one is in this picture it is separately showing. In the P&ID it is showing integral part. So one is the important parameter is here gas pressure. Gas pressure, to maintain constant pressure in absorber, pressure control system installed in gas line and gas pressure controlled by PCV at its set point. Look at here, this is the absorber outlet. The gas is, sweet gas is releasing and entering to outlet knockout drum, and it is going out. See, there is a control valve is there, and this one, then the blue color PC is there. So PC is there and control valve is there. So this pressure control system is controlling the entire pressure in the absorber. That is, the pressure is very critical parameter in the absorbing system. So gas flow is another typical parameter which influences the performance of the absorber. Falling below the specified design range will result in loss of efficiency. Rising above the design range will result amine carryover. Have a look at that one. This is the flow line. It is here. Flow control valve is there, FC is there, flow control valve in the inlet before inlet separator, or you can say before inlet knockout drum. So pressure control system and flow control system. Sometimes in some location I have seen that one this pressure control system and flow control system may be cascade. What is cascade I have discussed in our previous instrumentation control system section. So have a look at that one to understand what is cascade control system. So it's cascading, that one flow and pressure is cascading. So it will provide a efficient operating system and controlling both parameter very well. So gas flow at its design condition and must maintain a constant flow. FCV installed in a sweet gas outlet lane. Here it is written outlet lane, but in this picture it is installed in inlet lane. FCV installed and cascade with PCV. That is what I told. Sometimes it will cascade with PCV, and sometimes ulta also, because the PCV can install in inlet and the FCV can install in outlet. Some logic, but both systems are working in and around the world. Both the pressure and flow control system will maintain a constant design pressure and flow. That is very important. So pressure and flow parameter is very important and will affect the performance of absorber. That is the important fact. Next important parameter is a Linamic temperature. So Linamic temperature is the solution temperature must be kept at least 7 to 9 degree or 5 to 7 degrees C above that of incoming sour gas temperature. That is important. The incoming sour gas temperature, whatever the temperature is there, the solution temperature should be just above, higher than nearly 7%. This is required to prevent hydrocarbon condensation, which causes foaming in the tower. So otherwise hydrocarbon will condense in each tray or in the packing section, and it will causes foaming in the tower. That is very important in what is the temperature. According to that, you see the temperature is the outgoing gas temperature also we are checking, and inlet amine temperature after the cooler. Different type of cooler is using lean rich amine exchanger and fin fan cooler or normal cooler to maintain the temperature at the entry point, proper temperature at the entry point. Otherwise causes hydrocarbon condensation and foaming will happen inside the tower. Another important parameter is the inlet knockout drum. We have discussed that in this picture. Inlet knockout drum is the integral part, or it can work as a separate vessel. So liquid carryover with sour gas to absorber can create a number of operational problems, including foaming, equipment fouling, high corrosion rate, usually resulting loss of efficiency, solvent amine loss, and difficulty in meeting sweet gas specification. So the inlet knockout drum is designed for separating maximum amount of liquid component and other contaminant inside this knockout vessel. That level should not increase at any cost, and frequently that level is controlling by a LIT and LIC. See the LIC is here. LG level glass is there, level transmitter is there, level control system is there, level indicator control is there, and it is connected to a LV. This is the control valve, LV. So that this control level control system will make sure that the frequent level maintaining at its set point. So this is the if the level is the sour gas, this efficiency is not working, this liquid removal is not working here, it will create a number of operational problems, including foaming, equipment fouling, high corrosion rate, usually resulting loss of efficiency, amine loss. So in meeting that one, sweet gas absorption, remove sweet gas efficiency. Another one is rich amine level in absorber bottom. In another one is in absorber bottom, after absorbing the H2S amine settle in the absorber bottom. This is absorber bottom. That amine also we have to remove improperly, because the gas is entering from here through amine, and if that amine level is increasing too much, the flooding will happen and amine carryover will increase with sweet gas. Sour gas. Maintain rich amine level in absorber bottom to avoid amine carryover with sour gas, and LCV cascade with FCV to maintain constant level and flow of rich amine to regenerator. Here also simply LCV is showing here. See the level transmitter, level indicator controller, and LV level control valve. But what it is, the text is explaining about this LV can cascade with the inlet FCV also. When the level is too much increasing, they can reduce the flow. When the level is decreasing, they can increase the flow. So it can cascade with the flow also, level cascade with the flow also, or independent level control system can work to maintain a proper level in the absorber bottom. That is the absorber bottom, that one. So if the absorber bottom rich amine level is increasing, that may create lot of problem, operational problem we discussed about just earlier slide. Same problem can explain an amine carryover will increase, that will decrease the efficiency of the operation. Now the various important parameter, pressure, temperature, level and flow in absorber is very critical. Of course amine purity also critical, but amine purity will taking care in the regenerator. So this is amine regenerator area. So typical this is DCS output, DCS screen is showing here. In this one I didn't have a proper P&ID for amine regenerator in my stock, but that way I used this one. So the rich amine after absorber bottom, after heating, then heating in various heaters, Linamic rich amine heater and heat exchanger, it is heating and maintaining a preheat temperature around C102, almost warming temperature at 102 entering here, and a flow control system is also here. It is the rich amine flash shower or amine stripper feed. See, amine stripper feed, there is a cascading system is there, FC is there, and there is one no, there is no cascade, it is a flow control is there. So it is cascading with from amine stripper, there is a level is taking. So it is entering here, and the process briefly explained. The amine rich amine entering here, it is coming down and enter to, it is it need heat. Here it is high temperature and low pressure system, and it is working on the principle of boiling point difference. So to create a higher boiling point, difference in boiling point, heat is the driver here. Heat is the energy is providing by reboiler. So entire amine solution, amine plus H2O solution taking to a kettle type reboiler. In that one, providing heat by steam. See 3-point bar, steam is coming, steam is in the tube side and amine is entering the shell side. And the heater providing required heat is already received from the steam, and the amine, heated amine at entering to the bottom of the stripper at around 121, 120. Actually it is 115 to 120 degrees C, but here it is showing 121 degrees C entering here, and it is moving up and mixing or reacting or interacting with the incoming liquid, this one, and light gas is entering up and going up, entering up to here. See, the pressure is a very low pressure, 1 bar, and temperature is higher, it is 108, just to above than the water temperature. Actually it is nearly 102, 103. So that can only H2S can escape from the stripper outlet. So slightly water carryover will be there. Amine maintaining amine should be inside the vessel. This area, a slight condensation cooling the temperature, that amine will keep inside to prevent amine loss at minimum. And here it is the condenser is there to cool that one, to separate any water, amine and H2S. So after the cooling it is around 53 degrees C, and it is entering to the accumulator after the condensation. So it will separate here in three separation. One is a gas separation here, that is acid gas to the flare or to another vessel for acid gas recovery, and the water and amine is back to the system. See, back to the system, and using a reflex pump to enter to back to in the stripper top. So this area temperature can maintain to the back for the reflex flow, that we can maintain here around 53 degrees C. See, it is the reflex temperature is around 53 degrees C. So that create inside around 102, 103 degrees C can maintain here. So this is the process here. Reboiler is providing the required energy for the stripper. So this is the process. So here in the regenerator, what are the various process parameter is influencing? One is the regenerator temperature, that I told you in earlier slide. Reboiler temperature, that is in the reboiler bottom, regenerator bottom, maintained around 150 to 126. That is here. It is around it is here 121 degrees C. That is here, and to get more vapor, water vapor boil off, excess temperature. And the problem is here, too much high, very high temperature can create around 38 degrees C, amine decomposition start. So you should not cross above 125 at any cost. So to maintain that one, here see the steam is entering here, and steam is going back. There is a temperature control system is there. See, the FC is there, temperature control system is there. Temperature control system cascading with this another one with the temperature control system. Normally it should be a temperature control system cascade with the temperature indicator, temperature controller. See, temperature cascade with the flow control valve in steam line, maintain constant temperature in the reboiler outlet. So this temperature is maintaining with the temperature and flow cascading. That we can make it sure that the temperature should be constant and maintaining proper temperature in this outlet. And amine level is also very important. If the amine level should not increase above the set point, so that one it can, amine carryover can increase. Lean amine level maintained in the regenerator bottom, that this area, using a level control system installed in surge tank outlet. That is also here in this outlet system, we can using a level control system. Another important control system using in the reflex control system. Reflex will lower the tower top temperature. So in the reflex system, I explained that one. The reflex system, this is a reflex system. It will keep the temperature here in around, see, 108 actually showing nearly 102, 103 should be sufficient here, and that is a reflex will maintain the temperature. Reduce the amount of the heavier component from the vapor, leaves lighter component to the column. Only heavier component is here is amine. So amine will keep inside and leaves the lighter component, that is acid gas plus water. So you know that when water is boiling at 100 degree, just above 100 degree C and at 1 bar. So that is so amine temperature is around 138, 125 can start vaporizing and decompose. So that will not happen. So maintain that temperature here using a reflex system back. And more reflex means more distillate purity. More reflex is there, more distillate purity here. And even more reflex create flooding and increase reboilerability. So reflex is more than the design value. So it will create here more temperature dropping here, and the heat exchanger and reboiler duty will be higher. So to maintain that one, see the control system is there, FT and LC. Here in the accumulator there is a level control system plus cascade with the flow control system. So level and flow is cascade here. This is the control valve here. So always the level is maintaining and flow is also maintaining. So maintaining a proper temperature at here around nearly below 105 degrees C. So that is the concept here. So I hope you have very clear now the important process parameter like temperature and pressure, flow, level, etc. And this one here amine purity. Amine purity also very important. If you are maintaining these all design parameter, we will get very less amine carryover here, and pure amine around 98% pH purity, 98% purity we can get it inside in absorber. Using cascade control system that I have already explained. This is cascade control system is using in level in the reflex system. Please subscribe this channel for timely updation and information. Thanks for watching this video. Definitely we have to discuss about other safeguard system we can explain in this one, or we will start with glycol treatment, that is dehydration, gas dehydration in our next gas processing section 7. Thanks for watching this video. Bye bye for until our next video. Okay, thank you.